Hello, my name is Breden-Hardman. This is my 1.2 process of muscle contraction video. This video will explain the process of muscle contractions caused by a stimulus in a sporting environment. Firstly, you have the nerves transmission, which consists of your PNS, CNS, neuromuscular junction and sliding filament theory. The stimulus in this example is a tennis ball being hit across the court. It is received by the sensory organs, in this case the eyes. The information that the eyes see is processed and sent throughout the body as an electrical impulse. The impulse is then sent to the brain through the relay and motor neuron. Once the impulse reaches the brain, it makes a decision to contract the muscle so that the ball can be hit by the tennis player. The impulse then exits the brain and travels down the nerves till it reaches the appropriate muscle, where it meets the synapse known as a neuromuscular junction. ACH is released into the synapse, which allows the impulse to diffuse across. The impulse then travels from the junction to the muscle through T-tubules. The impulse allows calcium ions to be released into the sarcoplasmic reticulum. At rest, muscles are energized by ATP, otherwise known as adenosine triphosphate. During rest, troponin and tropomyosin are covering the actin binding sites, meaning that the myosin cannot attach. When the actin binding sites are free, the myosin arm would attach and create a cross bridge and pull the actin arm attached to the Z line into the middle of the sarcomere. The sarcomere will then slide together to shorten the muscle. This is muscle contraction. At rest, muscles are energized. Calcium ions are stored in the sarcoplasmic reticulum. When an impulse has been diffused into a muscle fiber, the calcium ions are also released into the muscle fiber. When the calcium is released, it bonds to the troponin, which then allows displacement of both troponin and tropomyosin. Once they are both displaced, a cross bridge can form. Diphosphate and phosphorus make the myosin arm attached to the actin binding sites and is used to make the actin pull the arm towards the center of the sarcomere in a sliding motion. The actin then slides into the H zone, making the sarcomere shorter. This is contraction. To form the cross bridge, there must be enough ATP available for use. It will be used to break the bond. The ATP is then broken down by ADP, which makes phosphorus as soon as the bond is broken, which is then used to create a bond again, which therefore the movement is created and cycles round. During sporting activities, muscles have to contract and relax in multiple different ways. The four different ways are concentric, eccentric, isometric, and isokinetic. Concentric contraction shortens the muscle during the contraction. An example of this would be when lifting the weight in a bicep curl. Eccentric contraction is where the muscle lengthens during the contraction. An example of this would be when lowering the weight during a bicep curl. The third type is isometric contraction. This is where the tension is created in the muscle, but it doesn't change in length or size. An example of this would be balancing on one leg, and the calf muscle would be the muscle contracting isometrically. The final type of muscle contraction is isokinetic. This is where the muscle contracts and shortens at the same speed. An example of this would be a isokinetic dynamometer. Thank you. This was my 1.2 muscle contractions video.